Here's the first section: Quantum Entanglement and the Fabric of Cosmic Memory, an extension of the Millar Cosmological Model, MCM. Introduction. Quantum entanglement challenges our classical understanding of space, time, and causality. Two particles, separated by vast distances, seem to share information instantly, what Einstein famously called spooky action at a distance. The Millar Cosmological Model, or MCM, offers a different interpretation. Entangled particles aren't sending signals across space faster than light. Instead, they remain connected through a shared dimensional frequency within the memory fabric, a universe-spanning structure built from the appearances and disappearances of quantum particles. This chapter reframes entanglement as shared memory tension, a phenomenon rooted not in space, but in memory itself. Section 9.1: Entanglement as shared memory tension. In the MCM, when particles become entangled, they're barbells, those tension structures linking matter and antimatter ends, temporarily share a common memory node in the memory fabric. This node acts like a quantum bridge, preserving their connection even if they're separated by light years. Here's the key idea: entangled particles aren't transmitting anything. They're both anchored to the same phase memory imprint. Measurement doesn't send information, it collapses that shared memory tension, not in space, but in the dimensional structure underneath. This way of looking at it actually fits with something called the ER equals EPR conjecture. That's a theory proposed by Maldacena and Susskind, which links wormholes to entanglement. But the MCM takes it further. Instead of needing spatial wormholes, it suggests there are resonance pathways, persistent memory bridges, created way back during the shatter at the birth of our universe. Section 9.2: Memory Fabric Topology and Non-Locality. The memory fabric acts as a layered record of every quantum event. Imagine it like a quilt, holding the standing wave patterns of cosmic history. When particles are entangled across this fabric, they're not exchanging information. They're vibrating together, held in a kind of phase lock that spans time and space. This idea aligns with several major findings in physics, like Bell's theorem from 1964, Aspect's experiments from the early 1980s, and more recently, Zeilinger's satellite-based entanglement work up to 2022. But again, the MCM goes a step further. It proposes that this memory node stays intact until something measures it, collapsing the shared resonance. Entanglement in this model isn't some spooky action. It's quantum memory made visible. Section 9.3: Implications for Physics and Cosmology. This view opens up some pretty big possibilities. First, it reframes non-locality. Particles aren't separated by distance at all. They're united in memory. Second, it hints that gravity and entanglement might actually come from the same thing: memory gradients in the fabric. And third, it suggests new ways we might test this idea, like looking for subtle changes in how long entanglement lasts over cosmic distances, or checking if the strength of that connection depends on the density of the memory fabric in different parts of space, or even searching for resonance windows, little echoes from other universes. Section 9.4: Philosophical and Spiritual Reflections. Here's where it gets really personal. In the MCM, memory is the architecture of everything that exists. If entanglement is just the echo of that memory, then maybe we're all entangled too. Not just with each other, but with the structure of the universe itself. Our thoughts, our choices, even our smallest actions, they become part of the cosmic quilt, stitched into the fabric of reality moment by moment. This perspective doesn't explain away the mystery. It deepens it. We're not just watching the universe happen. We are part of it, and in some deeper way, it remembers us. Section 9.7: Summary. When we look at quantum entanglement through the lens of the memory fabric, it stops being a weird exception. It becomes a fundamental property of how the universe holds itself together. Particles stay connected not by sending signals, but by sharing a memory tension. The idea of non-locality just melts away, replaced by something called dimensional coherence. When you measure an entangled particle, you're not collapsing something in space. You're resolving the shared pattern in the memory fabric. And this connection lasts, not because of distance, but because of how dense or sparse that memory fabric is in different places. So in the end, entanglement isn't just a quantum trick. It's the universe showing us how memory, resonance, and coherence build everything we see. Section 9.8, Conclusion. The Millar Cosmological Model trans how we think about space, time, gravity, and quantum physics. It turns them all into one story about cosmic memory. Entanglement isn't some rare loophole. It's proof that what once shared a moment of creation stays connected, locked together in phase, until something disturbs it. This isn't just a model of physics, it's a model of existence. Every quantum event writes the universe forward, one memory at a time, building a cosmic harmony that holds us all together. We're not separate, we're stitched together. And in the silence between measurements, the universe remembers us all.